Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of differential equations. And if I talk about the question which is given to us here from this topic, the question tells us let y equals y of x be the solution of the differential equation which is given by dy by dx plus 5 over x raised to 5 plus 1 into y equals x raised to 5 plus 1 the whole squared divided by x raised to 7, where it's telling us x is greater than 0. And further, the question tells us if y of 1 equals 2, then the question is asking you to find out what is y of 2 equals to. And if I talk about the answer choices that are given, they are 693 divided by 128. The second answer choice, 697 divided by 128. The third answer choice given to me, it's 637 divided by 128. And the last answer choice given to me, it is 679 divided by 1. So we need to figure out which one of the answer choices is the correct answer for the question which is given to us here. Let's first of all write our differential equation. So it is given in the form of dy by dx plus 5 over x into x raised to 5 plus 1 y equals to x raised to 5 plus 1 the whole squared divided by x raised to 7. So if I compare my differential equation with my general form that says dy by dx plus py equals q, from here I understand p is equals to 5 over x raised to 5 plus 1, and q equals x raised to 5 plus 1 the whole square divided by x raised to 7. So I have p, I have q with me. Once I have both of them, I can just find out the integrating factor here that says it is e raised to integral p dx. That gives me e raised to integral p in this case is 5 over x raised to 5 plus 1 dx. So from there, what I understand is if I divide by x raised to 6, so I'm dividing by x raised to 6 because the highest power I can have here in the denominator is x raised to 6. So if I divide both numerator and denominator by x raised to 6, it makes it 5 x raised to minus 6 divided by, you cancel 1x, so you get x raised to 5 divided by x raised to 5, which is 1, plus 1 divided by x raised to 5, which is minus 5 dx. So now what I can do here is put 1 plus x raised to minus 5 as t. That gives me 0. This becomes minus 5 x raised to minus 6 dx equals dt. So from here I get 5 x raised to minus 6 dx is minus dt. So now if I see 5x raised to minus 6 dx, this entire thing is dt. So e raised to integral of minus dt divided by 1 plus x raised to minus 5, we have put that entire thing as t, so it becomes t. Now if I solve this further, I get e raised to minus integral dt over t, and that makes it e raised to minus integral of log of t, and that becomes e raised to log of t raised to minus 1. And we know e raised to log of f of x, it's nothing but f of x. So you get this entire thing as t raised to minus 1, which is nothing but 1 over t. So I have 1 over t with me, and that gives me integrating factor as 1 over t. It's given to us as 1 plus x raised to minus 1. So that gives you 1 over 1 plus x raised to minus 5, I can write as 1 over x raised to 5. That gives me 1 over x raised to 5 plus 1 divided by x, that gives you x over x raised to 5 plus 1. So you have your integrating factor here now. Once you have your integrating factor, that is x raised to 5 over x raised to 5 plus 1, I can just use the idea of solution. So we know solution of such a differential equation is given by y into if is equal to integral q if dx plus c. So once I have this with me, y x raised to 5 over x raised to 5 plus 1 is equals to integral x raised to 5 plus 1 the whole squared. Q basically was, if I see, this is entirely q. So once I have p and q is x raised to 5 plus 1 the whole squared divided by x raised to 7. If we know x raised to 5 divided by x raised to 5 plus 1 dx plus c. Now once I have this, I get this as y x raised to 5 divided by x raised to 5 plus 1 equals to 1 x raised to 5 plus 1 gets cancelled, 1 x raised to 5 gets cancelled, and this becomes whole squared. So integral of, you get x raised to 5 plus 1 divided by x squared dx plus c. So from here, if I see the solution, I get x raised to 5 over x raised to 5 plus 1 with y equals to integral of this entire thing. So if I separate it, x raised to 5 over x squared dx plus integral of 1 over x squared dx plus c. So from here I get integral of x cubed dx plus integral of x raised to minus 2 dx plus c, and that gives you y x raised to 5 divided by 1 plus x raised to 5 equals integral of x cube is x raised to 4 divided by 4. Integral of x raised to minus 1 minus 2 is x raised to minus 1 divided by minus 1 plus c. So y x raised to 5 1 plus x raised to 5 equals x4 divided by 4 minus 1 over x plus c. Now this basically becomes my entire solution of the differential equation. Now once I have the entire solution of the differential equation for this entire thing given, let's try to solve it with the conditions which are given to us. So we have been given at x equals to 1 y equals 2. So let's use that condition to find the constant c. So at x equals to 1, I'm putting y as 2. So let's put that. So y is 2, x is 1. So you get 2, 1 raised to 5, which is 1 divided by 1 plus 1 raised to 5. So 1 plus 1 equals 1 raised to 4, which is 1, 1 divided by 4 minus 1 divided by 1 plus c. So you have this entire thing, and now further if I see, it becomes 2 into 1, which is 2 divided by 2. So cancels out and becomes 1. So 1 plus 1 minus 1/4 is c. So c becomes 2 minus 1/4. That is 8 minus 1, 7, 7 over 4. So I have my solution of the differential equation, and in that I also got the value of c, that is the constant, that comes out to become 7 over 4. So you get your entire solution of the differential equation, which is y x raised to 5 divided by x raised to 5 plus 1 is equal to x raised to 4 divided by 4 minus 1 over x plus c, which is 7 divided by 1. Now the question is asking you, what is the value of y of 2? Y of 2 means we have to find at x equals to 2, what is the value of y. Let's do that. So let's just put at x equals to 2. So if I put y 2 raised to 5, which is 32. Here you get 2 raised to 5 plus 1, so 32 plus 1, 33 is equal to, here you get 2 raised to 4, which is 16, 16 divided by 4 minus 1 over 2 plus 7 over 4. If I solve this, 16 over 4 plus 7 over 4, which is 23 over 4. And if I change my denominator of the second part also to become 4, I'll multiply both sides with 2. That gives me minus 2 over 4, and that gives you 21 over 4. So you have your entire equation as 32y divided by 33 is equal to 21 divided by 4. So if you see, y becomes 33 into 21 divided by 32 into 4. 32 into 4, which is 128. 33 into 21, if I multiply, 21 threes is 63, 6 carry, 21 threes is 63 again, 63 plus 6 is 69. So that makes it 693. And from there, I get at x equals to 2, the value of y is 693 divided by 128. That matches with option A. So A becomes the correct answer here for the question which is given to us. I hope you have understood how to solve this type of questions on differential equation. So we were given a differential equation in this form. Once I had that, I got the value of P and Q. I just found out the integrating factor here. Solving the integral, I got integrating factor as this, and then I just used the idea to find the solution that gave me the entire solution of differential equation. I put my first conditions at x equals to 1, y equals to 2 to get the constants value, and once I got that, I just put x equals to 2 to find the value for y which is asked to us. That matches with 693 over 128. That makes the answer to become option A. So A becomes the correct answer here. I hope you have understood this. I'll see you again tomorrow with some other question from some other topic, and we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing every day, please do like the videos as well and do subscribe to my channel, and share these videos with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions which we are solving on everyday basis. Thank you.